Hi everyone, I'm Melanie, Math Content Specialist here at Zinkers. Let's take a look at another digital SAT question and how we can use Desmos to help us solve it. This question says, the table shows three values of x and their corresponding values of y, where y equals f of x plus 4 and f is a quadratic function. What is the y-coordinate of the y-intercept of the graph of y equals f of x in the xy plane? Lots of information here in this question. Let's start by underlining a few of the most important pieces. So first thing I notice is the fact that we have values for y equals f of x plus 4. So these three xy coordinates here are for y equals f of x plus 4. The question is asking us for the y-intercept of y equals f of x. So whatever y-intercept I can find with these 3 points, I'm going to have to subtract 4 in order to give me the y-intercept of y equals f of x. So let's also start to think about some of the things we know about quadratic functions, right? And we do know this is a quadratic because, again, another important piece of information, the question tells us it's a quadratic. So what do we know about quadratics? We know that they are symmetric about the axis of symmetry, right? So this axis of symmetry is the vertical line where if we folded the parabola in half, we would get perfect mirror images on either side. So just something to keep in mind. If I were to just kind of give a sketch of what this parabola might look like, I'm not sure if it opens up or down quite yet, but it's going to look something like this. And obviously, again, my axis of symmetry is going to be just kind of this point down the middle. I'm going to now take a look at my coordinates, the coordinates that the question gives me. And what I'm noticing is that if I move up or down 2 values from this middle coordinate here, I'm going to get the same y value, right? So if I subtract 2 and go down to 21 on the x-axis, I'm at -8. If I go up 2, I'm also at -8, which tells me that these points are symmetric around this middle one, 23,8. And what that means is that 23,8 is our vertex point. So if I were to, again, just kind of give you a sketch of what these other 2 points look like, maybe I have 21, -8 down here, and 25, -8 down here. So that just, again, kind of gives me a picture. And this kind of tells us also that the parabola might open downward. These kind of coordinates give us that hint. So now what I'm going to do is use the fact that I have this vertex to write an equation for what this parabola might look like in vertex form. And if you remember, vertex form looks like this, where h and k are the coordinates of my vertex. A is that first coefficient, which tells me if it opens upwards or downwards. I'm not quite sure yet, so I'm just going to leave A as is, and then fill in my 23 and 8, where they should go in my vertex form. And again, just keeping in mind this minus sign is how it should be. So now I have an equation that I can plug into Desmos. And I'll plug it in exactly how I see it, leaving that A value there. I'll talk about that in a second. And then when I'm prompted, I'm going to add a slider for A. And if we look at that, we'll zoom out a little bit here. What that does is allow me to play with the value of A. So here I can kind of flip it up or down. I can see what happens if I increase A, decrease A, just lets me play around with it. I'm also going to take the points that this table gives me and plug these into Desmos as well. So I'll plug in the point 21, -8, and I'll plug in the point 25, -8. And now my goal is I want to move around A so that this parabola intersects these 2 points exactly. That will give me the graph of y equals f of x plus 4. So let's do that. I'm just going to move A, start to move A around, and we can see that if I go more positive, so to speak, I'm not getting any closer to going through these green and purple points. So I'm actually going to try to go negative with A and see what happens. And we can see, oh yeah, we're getting a little bit closer. And I'll zoom in a bit more. I drag over. I go more negative. I'm going to get really close. And it looks like at A equals -4, this parabola goes through my points exactly. So perfect. So now we have, again, the graph of y equals f of x plus 4. If I want the graph of y equals f of x, I'm going to have to do a little bit of work here. But first, let's find the y-intercept of this graph. And if we start to zoom out and look for that y-intercept, we can see we're going to have to go all the way down here, which is fine. Just kind of keep scrolling until you find it. Looks like it's starting to cross. And Desmos is great with this feature where it kind of draws your mouse to points of interest. So here our mouse is being dragged to this point right here, 0, negative 2,108. So I can tell you that the y-intercept of f of x plus 4 is 2,108 negative. And again, what I'm saying is that that is the y-intercept of f of x minus 4. Or plus 4, if I want the y-intercept of y equals f of x, I'm going to have to subtract 4 from that. And that's going to give me negative 2,112. That will be the y-coordinate of the y-intercept of graph of y equals f of x. Is there another question that you want to see? Make sure to leave a comment down below, and don't forget to like and follow our channel for more digital SAT content.